This is lesson 7.1, dynamic equilibrium. So the definition of equilibrium is really important. Equilibrium is when the rate in the forward direction for a reaction is equal to the rate in the reverse direction. So far in chemistry, we've only studied reactions that go one way, towards the right. However, there's some reactions that go backwards towards the left. And when this happens, when they achieve equilibrium, there is no change in the amount of reactants or products. It's like a seesaw balancing act. So here's an example. Initially, you have bromine liquid, and the bromine is evaporating into a gas. And at some point, you reach the state of equilibrium where the bromine gas is also coming back down, hitting the surface, being sucked in by these intermolecular forces and becoming a liquid. So at the same time as these are coming back into a liquid, liquid bromine is also evaporating to the gas. And when this occurs at the same rate, we say that the system is at equilibrium. Now, equilibrium can only occur in a closed system. So remember, closed systems mean that you cannot exchange mass with the surroundings. So here's an example of two hydrogen iodide gas. The equilibrium is shown because they go back and forth, meaning a double-headed arrow goes to hydrogen gas plus iodine gas. So this is dynamic in that both the forward and the reverse reactions are still occurring. So this reaction is occurring and this reaction is occurring. And you can see this reaction in the flask, and you can tell that this is occurring because the iodine gas is purple. So reversible reactions are those that occur in both directions. There's 5 characteristics of equilibrium. Remember, the equilibrium is reached when the rate of the forward reaction is equal to the rate of the reverse reaction. This is always dynamic, okay? The reaction has not stopped, but the forward and backward reactions are occurring at the same rate. It only happens in a closed system, meaning that matter cannot be exchanged with the surroundings. The concentration of the reactants and the products stay the same, even though the reactants are turning into products and the products are turning back into reactants. Because you have that both ways, the concentration actually stays the same. There's no change in the macroscopic properties, meaning that the things you can see do not change. For example, color will not be changing if it's at equilibrium. And equilibrium can also be reached from either direction. You can start with all products and still reach equilibrium, because remember, it also goes backwards. So from either side of the reaction, you can reach equilibrium. The equilibrium position is the proportion of reactant and product in the equilibrium mixture. When you have predominantly products, we say that the equilibrium lies to the right. When we have predominantly reactants in our mixture, we say that the equilibrium lies to the left.